Okay, so for second part, we have done VT, we have done ST, VT, and AT. Now I want you to refresh your mind again. We learned another two extra graph where they call AS and VS graph. Okay, try to separate what we learned in the first session. First session, we learned we learn about S versus T, V versus T, A versus T. Before first session is in the first session we learned about time. Now we learn about two type of graph where the x-axis is displacement, okay, or position. Okay, it's a position S. So let's say you are given acceleration versus position graph. Let's say you get this kind of graph. And at point 1, I label as 1. Take note, at point 1, you extend down, you are touching position, not position point. I label as at sub 1. You extend to the y-axis, which is your acceleration, you get A sub 1. What information we can extract from this graph? You have position, you have acceleration. Can you link AS graph to generate V versus S graph or another type of graph? Can you change this one to this one? Try to think what are the equations that we learned before this that link acceleration, velocity, and position. Try to change A versus S graph, this position graph, to velocity versus position graph. Okay. How we get this dot here? Okay, how we get this dot here with position S1 and velocity 1. Okay. Just a side note and reminder, every time the line touch the intersection of your y-axis, it is an initial element. Okay, so if you're having a V that touch the y-axis at this point, it means initial. Okay, time 0, time 0. For the A versus S also same. So from here, you can know that there's a delta V here. Okay, there's a delta V here. Okay, let me see if I go too fast. Okay, correct. Now we're going to see how you turn this one to this one. Okay. Process, we start with one equation. Recall there's a portion in our PowerPoint slides. We did this one. When we relate the velocity and acceleration with the time, recall that one session we talked about this one. And by using velocity definition and acceleration definition, we rewrite the dt on the left-hand side for V and A. Then the change of time will be the same. The change of time between V and A will be the same. So you can equal this one to this one. Okay. Go to this one. And then we move this one A to left-hand side. This one we move to right-hand side. You arrive at this equation. Take note, when you use this equation, you have to understand that the behavior or motion happen at the same delta t or dt time frame to use this formula, okay? Because the background of this equation, we put the dt same for v and a. Okay, this one we derive from definition of acceleration and velocity. That's why we arrive at a ds equal to v dv. So we have been repeating every time we see ds, we see dv, something ds, something dv, or ds or dt, something d one side, something d one side. We know that the next step we use integration procedure. Okay, so you see this equation that we derived previously. So we will integrate this side and integrate this side. You arrive at this equation. Okay, here to here. Maybe a little bit fast for you. I'll give you maybe 10 seconds to process information from here to here. When you integrate ADS, you get the far right. Let me see if I go further. Okay, I can go up to here, right? So, yeah, so you can get this one and this one. How you get this one? You integrate V versus dV, right? Integrate V dV. What do you get? You get V, and here is 1. 1 plus 1, you get 2. So you get V square divided by 2. Again, if you don't know what I'm talking about, go back to your integration chapter in mathematics textbook. Refresh how to do integration x dx. When you integrate x dx, you get x squared divided by 2. Now you change the x to v, you get v squared divided by 2. And again, you integrate from lower limit to upper limit, from one point to another point. You substitute from 0 to 1. That's why you get v1 squared minus v02. Here to here is integration steps. Nothing to do with engineering dynamics. Here to here basically is integrations in mathematics. Okay, so important that you understand how you arrive at this equation. It starts from something that we learned before this, that we start with definition of velocity, definition of acceleration, and we only study what happened in that particular time frame. We equal them together, we write them in the linear equation, and we see ds dv, we integrate, we get the yellow color equation. By using this equation, you look at the graph, A versus S, A versus S integration. What do you think you will get? A ds, and you see A ds with the integration, and you are seeing A versus S graph with a curve. Relate to previous slides that you see before we take a break. This one actually area under the graph of this curve. If you use integrate A ds, you look at the graph A versus S and you have a curve. Integrate this one, you'll get area under this graph. Okay, this side is area under this graph. I'll highlight with red color there. So you can quantify the area under the graph by using the skill that you learn in mathematics, the approximation in graph, Simpson method, or trapezium method to find area under graph and all this, right? So yeah, but anyway, that one is for on the mathematics chapter. But what is important is relate this equation to the graph. So By using this one, I pull this equation into the graph. I put side by side just to help you in your revision. And I put in the limit there. You see, here we don't have limit, but I put in a limit. 0 to S1 means from the origin to S1 point, ds. How do you know we are using 0 to S1? Because we are integrating ds. And this side we can calculate. Okay, we have one value on the left hand side. This one is just a substitution of value, or this one minus this one, you'll get value, right? Okay. So basically you're using this concept to find V0 and V1. So because normally you know what is the initial velocity. Normally you know what is your initial velocity. Okay. It's how you link A versus S graph to V versus S graph by using this equation. We want to determine acceleration at any position of inside the graph. Can we determine? Again, use back the same equation. A ds equal to V dv by looking at the motion change at that particular time, dt. We still use back the what happened in that dt, link velocity and acceleration together, bond them together, we get this equation. Okay. Rewrite this equation if you want to find any missing parameter. For example, by looking at this linear equation here, A ds equal to V dv. If the question asks you to find acceleration at any position of s, so here you have s, position, you have velocity, you have velocity dv. So what you do, you move the one that you don't want from left hand side to right hand side. You will get V dv ds. Okay, V dv ds. So you go back to the V versus S curve or V versus S graph. Just now, when you have a curve and you look at that point and you do differentiation of dv ds or differentiation of your y-axis and x-axis, because your y-axis is V, x-axis is S, you do differentiation of that point. You focus on that point, you take point y versus point y differentiate versus x-axis, you get slope or gradient. Okay. Try to recall what you learned in mathematics. Linear equation, you having y equal to ms plus c. Recall back how you get the gradient of the m. M, you take delta y divided by delta x. Same concept apply here, only the axis changed to V versus S. Okay. Just highlight for you lah. At this point, the slope is dV ds. Okay, don't confuse with the V versus T graph. Huh? We are now at V versus S graph. Take note on that. Okay, don't confuse. Huh? Don't confuse V versus T graph. Now we are at V versus S graph. So you can calculate. You can calculate the acceleration at that particular point at point 1, or you can calculate A1 value equal to V times the slope of that point or gradient of that point. Okay, so if you want to find A1, what do? You want to find A1 on the left-hand side. A1, what do? If you refer to this graph, what is V? V is a final velocity. You take V1, substitute here. Slope you can find from the equation of the graph. You do differentiation using the graph equation. You do dV over ds, you do differentiation. At this point, you multiply inside, you substitute inside the value, you get this point. Okay, so far we cover how you convert A as graph into V as graph. Let's look at one tutorial question, then we call it a day. Right? Okay, we are now at example number 4. Now a bicycle moves along a straight road such that the position is described by the graph below. We'll be given a graph later. Construct VT graph and AT graph for the time from 0 to 30 seconds. Okay, study the question. What does the question want you to do? You are given a scenario, a movement of an object moving in the straight line, and you have a limit of time from 0 to 30 seconds. How do you process this information? The question asks you to construct a graph. Two graphs, AT and AT graph. VT and AT graph. So, if you're given this graph, in your tutorial question that you download from Moodle, you download from Team, you will see the graph information on the tutorial question, right? So I just slowly show you the information. So this is the one that you see on the tutorial question. So the tutorial question comes with S versus T graph, and there's a two region of motion. One is from 0t to 10 seconds. We'll give you a displacement of equation 0.3t squared. We have two motion there, two different motion. That's why it fall under this word. My finger cannot go up. That's why you see the word erratic motion. See the difference of graph that we discussed so far? Do you see the difference of graph compared to the first session graph? If you have erratic motion, it means you are you have a combination of different motion. So for the first 10 seconds, the displacement, you need to use this formula. After 10 seconds to 30 seconds, there's another type of motion. As you can see here, can you imagine the motion of the bicycle? For the first 10 seconds, the rider keeps some time to increase the distance. 0, slowly, slowly cycle the bike from 0 to 30 meters. After 10 seconds, he start to speed up. That's why you see there's a linear graph. This is a linear equation. S equal to 60 minus 30. There's a linear graph, means you speed up with the distance, right? So this is a quadratic curve. This is a linear equation. Recall back what you learned in mathematics. What is the shape of quadratic curve? What is the shape of linear equation? Linear equation, y equal to mx plus c. Quadratic equation, y equal to ax squared plus bx plus c. So you can see the form of equation you have. Now, anyway, back to the question, you need to convert this one to V versus T and A versus T graph. How to score point in this kind of question? First, always give definition of the parameter that we want you to find. In this case, we want you to find V and A. So you give the definition of V, mathematics definition. What is V? Right? What is A? So information you have a, you have a ST graph, right? And which equation that you use? Again, give definition of velocity. V equal to ds dt. Acceleration, and acceleration equal to A equal to dv dt. So we look at velocity first. We slowly develop AT graph first, then we go to VT graph, then we go to AT. So for ST graph, we want to convert from ST graph to VT. We will use differentiation. And in this case, we have 2 slot time frame or 2 slot of motion. That's why I call erratic motion. So from 0 to 10 seconds, again, you will see the differences. In exam, don't add 1 slash here. Don't add slash here. If you get slash, it means it includes 10 seconds. So from 0 to before 10 seconds is this one. And from 10 seconds to 30 seconds is this one. You have the equation. Can you do differentiation for this slot and this slot? Let's try your differentiation skill. Who want to try? Who want to try to answer this one? When you differentiate this one, what do you get? ds dt, what do you get? Anyone want to try? Stephen, when you ds dt from 0 to 10 seconds, what do you get? When you use this differentiation equation, you differentiate S equation, what do you get?
A few minutes, sir.
Again, Stephen, can you repeat your answer? Your mic is a little bit low. Cannot hear you. Stephen, can you repeat your answer? When you differentiate S equation, S equal to 0.3 t, when you differentiate S versus t using this equation, what is the velocity equation for time frame of 0 to 10 seconds?
Sir.
The answer is what? V equal?
You said the t is from.
No, you are given equation, right? It's equation, right?
Hello, sir.
Now I want you to, now we are converting ST graph to VT graph. So we are giving the information of S, or displacement or position. Now you know the definition of velocity. Velocity equal to ds over dt. Or this one is a differentiation formula. You are given one equation. Let's say this is you need to find dy dx. This is y equal to 0.3 x squared. Dy dx equal to what? Just want to test your differentiation skill. What do you get if you differentiate this one over time? Give me the formula. The result when you differentiate, you're given v equal to ds over dt. You are doing differentiation procedure now, not division. You are doing differentiation formula. You are doing differentiation procedure. What do you get? Stephen, do you understand what I'm asking about?
Sir, is it 6 meters per second?
No. You understand what is differentiation, Stephen?
Yes, sir.
Velocity is a differentiation of displacement over time. You are given one equation here. What is ds over dt? What is the answer for ds over dt? What is the
0.6 T.
The answer is 0.6 t, correct? That 0.6 t equal to what? Equal
Velocity.
to velocity for the time of 0 to 10 seconds. Okay, Stephen, continue. What happened to the velocity from 0 to 30 seconds by using this equation? What is a velocity equation for 10 to 30 seconds? You can do this one, right?
ds over dt
Yeah,
is 6
6, correct. 6 what? What is a unit?
meters per second.
Correct. Anyone have question why Stephen answer in that way? If you don't understand, let me know. You don't understand why suddenly Stephen talking like all these numbers come out. You don't understand. Any one of you don't understand why suddenly you get. Okay, why suddenly you get 0.6 t meter per second? Any one of you? You don't understand this one. Anyone you? You don't understand why suddenly you are given this formula, and then for this slot from 0 to 10, suddenly you can find the velocity equal to 0.6 t. Any one of you don't understand, I can explain. If you don't understand, don't keep quiet. Huh? If you keep quiet, then the thing that you don't understand is going to snowball. Huh? Because we're going to learn, we're going to adapt what we learn today to the next class. Okay, I assume all of you know. You do the same for 10 to 30 seconds by using the displacement equation. You differentiate the displacement over time because velocity equal to differentiation of location or displacement. ds over t, you get 6 seconds, 6 meter per second. Again, last chance for you to ask question. If you don't understand why we can say 0 to 10 seconds, our velocity equal to this one, 10 to 30 equal to 6 meter per second. Ask question now if you don't understand. Huh? Okay. Now we have two value here. Can you plot these two value in the graph? Sorry for this one. First steps is to, because the question asks you to transfer S versus T graph into V versus T graph. So what do you do? Once you get the equation, first steps is that you draw the axis. V versus T, remember the unit, meter per second. In your answer, T is second. So if this kind of question come out in test or exam, you accidentally forget meter per second or unit, you forget to put in second here. Let's say this axis and this axis give you 2 marks. You only get 1 mark for 2 axes. I will discount 50% from the marks given. Because if you don't write unit, it means something else. It means kilometer per hour. It can be cm per second. It can be other things. For this module, pay a little more attention on the unit. So after you plot the V versus S axis, again, when we convert, we focus on the time. So we have two time slot here, 0 to 10. So you label 0 to 10, you draw one line, 10 to 30 second, 10 to 30 second, you draw one line. As you can see here, what does this equation means to you? This is a linear equation. Y equal to mx plus c. Y equal to mx plus c. Your y-axis is v. M is your gradient. X is your t. Plus c. There's no c there. C0 means you start from origin. How you know is going up or going down? M positive going up. You get negative going down. Go and repolish what is how to plot linear graph in your mathematics class note. So in this here, you just apply how do you transfer linear equation into graph form. How do you know what point to stop at? So from here to here, you know that this one is 10 seconds. So 0 to 10. However, what is the value of this point to this point? What do you think? What do you think? This one is 10, right? 10 seconds. 10 seconds go up, hit this point. What do you think this value will be by using this equation? You know your t, right? You know your t, right? Let me ask question. Or who want to answer? Shilton, are you there?
Is it 6, sir?
Yes. How do you get 6?
Substitute 10 into
Correct.
the t.
Okay, so quite direct. So here is 10. You go up because this line is a linear equation. So you substitute the last point of this point. This is 10. So 10 multiply 0.6, you get 6 here. Okay, means this one is 10. If you want to write coordinate in the Cartesian plane, your x is 10, y is 6. This point is 10, comma 6. Okay. So again, just highlight for you. This is a linear equation. Compare linear general equation to the one. Okay. So when t equal to 10 here, you substitute 10 inside here, you get 6. So you move to 6. This is how you get this point. How you decide where to stop? You stop at here, 6. So there will be marks for this value when you come to exam. Don't calculate and then you forget to put in your graph. You need to explain where is this point. Okay? Or if you're lazy, you can straight away give me a x and y coordinate. Also, I give you marks. If you're lazy to write here, you just put a bracket. Give me xy coordinate 10, 6. You also get point for that. You do the same for v. Okay, v equal to 6 meter per second from 10 to 30 seconds. This basically is a straight line from here to here. Again, you see this one as a linear equation. Y equal to mx plus c, or y equal to a constant value. When your y equal to a constant value is a straight line. So how do you plot this one? Actually, it's a straight line like this. It follows 6 meter per second. This is how you convert ST to VT. Okay. And here, just to highlight this one, because of straight line, if you do dV, if you want to find the, this just a, so if you want to find the velocity, You can do the differentiation from here, or you can do from graph also. If you want to find in the slower way, what is the velocity at here? You can take what is the final distance, 150 minus 30, because at here is 30. You see the graph on there. You take 150 minus 30 divided by the time between this one and this one. 30 minus 10, you still get 6 meters per second. Okay, this is how you check your answer. Okay, in exam, as long as you're able to produce the critical point or this important point, I'll still give you marks. All right, this is just an extra step to further confirm your answer is correct. Okay, you don't need to do these steps in exam or test. When you have V versus T graph, you can convert this one into A versus T graph. So you have VT graph. Use VT graph, convert to AT. Recall the definition of acceleration using V. So acceleration equal to V divided by T dV dt, or the change of velocity divided by the change of time. But basically, there are two meanings here. One is the change of velocity divided by time. Another meaning is that it's a differentiation of V versus T graph. It's a slope. It's a slope or gradient of V versus T graph. There are two meanings here. One is the difference of velocity divided by time, or it's a differentiation equation that you find the slope of V versus T graph. So by having understanding of A, look at the VT. We have two. Okay, I pull to the left hand side, the VT that you get. So if you get the wrong VT in the exam, basically it's snowball. You know, it will snowball the wrong answer to the AT. Basically, when I mark your VT graph, I know whether I should continue to mark or not already. Okay, you make mistake here, I don't need to mark for AT already. Okay, because you're wrong here, sure wrong here. Because it's snowball, you link the information from AT into VT into AT. So again, you copy the information that you get from the previous calculation. 0 to 10, you get V equal to 0.6 T, which is a linear equation. And 10 to 30 is V equal to 6 meters per second. So you want to plot the graph. You use the definition. From 0 to 10, you have this information. You use definition of acceleration. dV over dt basically is a differentiation procedure that look at this equation. 0.6 T, you differentiate over T, you will get 0.6 meter per second. So if you plot graph later on, you get A equal to 0.6, basically it's a straight line. So, and then this one, from 10 to 30, velocity equal to 6 is a constant value. You differentiate A using V information, dV dt. You differentiate a full number, you get 0. Okay, you differentiate full number, you get 0. If you have question mark how to do differentiation, go back to your mathematics class. Okay, I assume you already have the basic of differentiation. You have these two information, plot the graph, give the A versus T axis. Again, remind, always remember to put in the unit. Acceleration is meter over second square, time is second. So usually if this one is exam or test, axis will give you 2 points. Y-axis, x-axis give you 2 points when you draft, when you sketch. So if you accidentally you forget the unit, discount 50%, you only get 1 point for x and y-axis. And if you do not label, sorry, if you accidentally you do not label what is y-axis, what is x-axis, you want me to guess, I will not give you marks. I will put a question mark in your answer. question mark and your answer, and I'll put 0 for your graph because I don't know what you try to say. Okay, so and then put in the time frame. You know that you have 0 to 10, 10 to 30 here, and then you draw a straight line up just to know where to plot. So you know that from 0 to 10, your acceleration is the constant value 0.6. So you go to your graph, put in 0.6 here, draw a straight graph. What happens if it's 0? 0 means you don't need to draw anything. It basically is a line here. If you really want to draw, you draw a solid line here. Means 0 to 10, you get 0.6, and then suddenly drop to 0. 10 to 30, you draw another line. Okay? If you really want to draw. But if this question come out, you forget to draw also, I give you marks because 0 is 0. Okay, if you draw line also, I give you marks. Okay, so this is how we mark your paper. Okay, 0.6. All right, so we stop here and stop the recording.